Hey guys, welcome back to another video. Today I'm going to be taking you guys through LeetCode 36 valid Sudoku. This is another video as part of my raw and authentic LeetCode walkthroughs. So let's get straight into it. So this is a medium problem. Determine if a 9x9 Sudoku board is valid. Only the filled cells need to be validated according to the following rules. Each row must contain the digits 1, 2, 9 without repetition. Each column same. Each of the 9 3x3 sub-boxes of the grid must contain the digits 1 through 9 without repetition. A Sudoku board partially filled could be valid, but is not necessarily solvable. So really, all we care about are the numbers. So for instance, I'm pretty familiar with Sudoku, so I think it's just like, okay, in a row, if there's any repeating numbers, in a column, if there's any repeating numbers, or in a cell, any one of these 3x3 boxes, if any of them have a repeating number, then it's automatically false. So here, the output is true. As we can see, if you want to pause and have a look, there are no rows, columns, or cells, the 3x3 subgrids where there is a repeating number. And then here they say it's false, same as example 1, except with the 5 in the top left corner being modified to 8. So here, if this becomes an 8, there's also an 8 here, so that's not valid, and then there's also an 8 in the subgrid here, so that's also not valid. So I think in this problem, I'm gonna cover, there's gonna be 3 cases that you have to cover. So there's each row, each grid, each subgrid, and each column. I'm gonna start with the row and then the column, and then do the subgrid, because the row and the column seems pretty straightforward, but the grid might be a bit more tricky. So for this, so I'll say for row in range 9, okay? So basically what I'm going to do is I'm going to traverse each row by their indice in this. So it's a matrix. So for instance, like this position right here is going to be board 0, 0. It would be represented like this. Like this. 2 zeros indicates that here, this 0 gets us into the first list in the matrix, and then this one gets us the indice in that list. So we know for row in range 9, then we have to say for column in range 9 as well. So that way, this for loop gets us into each of these, and then once we're in, we have to check each individual cell. So what I'm going to do here is, once you're already in the row here, at this point, you want to check if there's any duplicates in this list. So what I'm going to use a set that keeps track of what numbers we've seen. And if we find a number in this for loop, if we find a number that is already in the set, so that means we've already seen it, I'm just going to return false, because that means there are repeating numbers in that row. So I'll use a set called seen here. And then basically, there's also decimal points. Those mark empties. So really, we don't really have to care about these. So I'll just say like if, let's do this. How about we say, like we set a value for cells. So we'll say cell is board, row, column. Just so we don't have to repeat this code, we can just say cell. So I'll say if cell does not equal to a decimal place, then we can work with that, you know. So that means we have a number. So we'll say if this number, if cell in seen, so it's already in the set because we've already seen it, then we return false. Otherwise, I'm going to go down here. I could say else, but I'm not going to, because it's not really necessary since this is a return statement. I'll say otherwise we can add the number to the cell. So this should hopefully get every case where there are repetitions in the rows themselves. Just to test it, I'm going to run it. It shouldn't really work because it's only the rows right now. But, okay, oh yeah, there's no, let's see. If none of these tests produce false, we should return true at the end. So let's see. Okay, so this returns true. And that's good because we know that there are no repetitions. This is a valid Sudoku, so it should return true. But if, say, I take this, let's take this, and I make another test case. Oh, I guess it's already there, right? And I just throw in like a 5 right here. This should produce false if it's working properly. Okay, it still produces true. Oh, no, sorry, no, I was looking at the wrong one. Okay, that's perfect. Okay, that means our row test case works. When you're working with problems like this, which often require a lot of code, you usually want to test each individual section, because that can help with debugging later on, so that you don't have to go back in and find exactly what the problem was. So now I'll just do the exact same thing that I did, but this time I'll do it the other way around. So this time I will go from the columns into the rows. So this time there'll be a set out here. It's literally the exact same logic. I'll just quickly type that up. It's basically just like the same as this. Okay, this should be good now, because now the only difference is now we're basically treating it as this is a row, this here is a row, and this is a row, and this is a row, and we're just iterating over each cell in each column basically. So we're going by column first and then row. And in the other case we're doing row. So this basically, this checks all rows, and then this checks all columns. And now we have to check each subgrid. Okay, let me think about how we could do that. So let's see. So one way that we could go about it is, so we know that this right here is 0 and 0. We know that this right here is 0, 3, this is 0, 6, and then this is 3, 0, 3, 3, 3, 6. So if we could start from the top left and then have another loop that adds like some sort of number in either direction, and that covers the entire, then that would be really good. So let's say we have, so we want to start with the 0, 0. So what we could do is we could say for let's just say row, and not a range. I'm going to say it's just going to be these discrete numbers, and then I'm going to say for column also in those discrete numbers. And then what you want to do is, now this gets you access into each of these. It gets you access to these cells, and then now you want another number that will go out and down. So we'll pretty much need, we'll need four loops. So for I'll just say I in range 3, and then for J in range 3. And now, so I guess we could have our scene out here. I'm just gonna keep it there for now. And then now what I'm gonna do is, now our cell is going to be like this. It's going to be board, it's going to be row plus I, and then column plus J. So basically, if you think about it, right, imagine here we start at 0, and then when we're working through this for loop, we also start at 0. So we're going to be here, and then what's going to happen is on the next iteration, we're going to increment this by 1, so that this is adding to our columns. So we should go down, right, down, no, sorry, no, we go to the right. Yeah, we go to the right, because this right here is going to stay at 0, and this is going to go to 1. So 0 and 1 would be right here, and then this is going to increment again, so we're going to go here. But then what happens is, this is now this is now completed its loop. So now we're going to step out and we're going to go to this loop, and this loop is going to bring us here. And then we're going to do the same thing where we add them in, and then we go down again to the next row, and we add these in. And now we've checked this. Now we want to check if we've seen everything, like if we haven't seen any numbers that we've already seen, and then that would return false. Otherwise, we just simply move into this, which is going to bring us into this subgrid, and then we just do the same thing, and then we work through all of them. So it should go like here, here, here. It should be in this order, how it goes through all of these subgrids. So now I'm going to say, once again, it's pretty much the same logic. So I'll say if cell does not equal to this, because we don't really care about those, then we'll say, then we ask ourselves if cell is already in scene, then we just return false. Otherwise we add it. So cell dot add, sorry, scene dot add cell. And then we just have a return true out here, and this hopefully, let's see. Okay, beautiful. Okay, so I'm pretty sure hopefully this should work. So now at this point, this is going to check all 3x3 subgrids. Okay, let's see how this works. Yeah. Okay, beautiful. That works. That's great to hear. Nice. Okay, well, I hope you guys enjoyed this video, and I hope you guys learned something, and if you guys think you can find potentially a better way, it looks like I've beaten quite a few people at this, so if you guys can find a better way though, let me know down in the comments below. I'll check it out. But besides that, I hope you guys enjoyed, and I hope you guys learned something, and I will see you in the next one. Bye-bye.